This is lesson 2.1 in Algebra 1. We're going to be writing and graphing solutions to inequalities. So an inequality is a mathematical way that we can compare expressions. Up until this point, we've all been pretty familiar with equations where we set values or expressions equal to each other, but sometimes they're not equal. Sometimes one value or expression is greater than the other, one is less than the other, or they couldn't still be equal. But a way that we can compare values or expressions is with an inequality. So some of the symbols that we use, since we're not using equal signs, are these guys right here. We call this one the less than sign. We do always read an inequality from left to right, just like words on a page, just like anything we read in math. So I wanted to write that down. We want to always read from left to right. All right, just so we don't forget. So we're reading what comes first, and then the symbol, and then what comes after. So this is a less than sign. What's first is less than what comes after. We could also say is fewer than. Either one of these expressions and others too kind of convey this sign right here. Okay, then we have the opposite symbol, which is greater than, the greater than symbol. If you see the phrase is more than, it's also referring to the same symbol. We've got the less than or equal to symbol, right? So this is when a value could be a number or it could be less than a number. Okay, so we use is less than or equal to. Is at most, the most it could be is a number. If we have x is less than or equal to 10, the most x could be is 10, or it could be less than 10. And then we can also say is no more than. And then opposite of that, we have greater than or equal to. We can also call that a phrase we could use to describe this is at least. And then is no less than. But it is very important you always read from the left to the right, just like words on a page. So when we write our inequality, and we'll have some examples here, we want to use our symbols correctly. So we're going to use that little table that I just showed you. Okay, so for this first one, it says a number, W, minus 3.5 is less than or equal to negative 2. So when we say a number W, obviously W is not a number, but it's a variable that represents an unknown number. So W minus 3.5, minus 3.5. Hopefully you brushed up on translating your verbal expressions to algebraic. And then we see is less than or equal to this little guy right here. So that symbol, if we go back up here, is less than or equal to this guy right here. So we're going to say is less than or equal to, and then negative 2. So this is our inequality here. Okay, B, 3 is less than a number n plus 5. So the number 3 is less than, and that's this symbol, a number n, so just an n, plus 5. So whatever n is, when we add it to 5, this whole thing is going to be bigger than 3. 3 is less than whatever this value will be. Okay, and then part C here, 0 is greater than or equal to twice a number x plus 1. So 0 is greater than or equal to, oops, I went too far. So greater than or equal to twice a number x. What does twice mean? If you do something twice, you do it 2 times. So 2 times x, and then plus 1. A little review and translating verbal expressions there when we're dealing with inequalities. All right. The next part of the lesson in the textbook is checking solutions of inequalities. We will get into actually solving inequalities in the next lesson, 2.2. But before we get there, we could sometimes just want to test out a solution. So if we have an inequality and we want to know if a number is a solution to that inequality, it means could we substitute that number in for the variable and make the inequality a true statement? Right? So whatever the solutions are to an inequality, we call it a solution set. Unlike an equation that has one solution, an inequality can have infinite solutions. It can have many, many, many solutions to an inequality. So we want to include that in our solution set when we do finally solve. All right, so tell whether, in these two examples, tell whether -4 is a solution of each inequality. So we're going to substitute -4 in place of x. So I'm going to kind of put it in parentheses here. Plus 8 is less than -3, and I'm going to substitute -4. So now I want to solve. -4 plus 8, if I'm at -4 and I come up 8, or I could switch these and say 8 minus 4. I'm at +4. Bring down my sign. And then I've got this -3 over here still. So I can't simplify anymore. Now I just have to ask myself, is this a true statement? Is 4 less than -3? Of course it's not. It's much bigger than -3. So this is not a true statement. So then we would say for this inequality, -4 is not a solution. Okay, part B, here's another inequality. We're going to use the same -4 in place of the variable. So we have -4.5 times x is greater than -21. Okay, so -4.5, I'm going to put x in here, is greater than -21. And then quick mental math. Negative times a negative we know is positive, so we can kind of ignore our negative signs here. 4.5, when we add it up 4 times, right? 4.5 plus 4.5 plus 4.5 plus 4.5, we get 18. And a negative times a negative is a positive, so we get positive 18. And that's greater than -21. So then we ask ourselves, okay, we can't simplify anymore. Is positive 18 greater than -21? Absolutely it is. So in this case, -4 is a solution to this inequality. It makes it a true statement. So we would say -4 is a solution. Now, it's just one solution. It's not necessarily all of the solutions, so we're not going to go much further than that right now. This is just showing you how you can test a number to see if it works as a solution to an inequality. All right, so now we want to talk a little bit about graphing the solution to an inequality. The graph of an inequality shows the solution set of the inequality on a number line. We will get into later graphing inequalities on a coordinate plane, but for right now, we're just graphing single variable, single answer solutions on a straight number line. So if I had an inequality solution like x is less than 6, and I wanted to graph that, I wanted to show my solution on a number line, first thing I want to do is represent or show my numbers that I'm going to be using near my answer. The most important number on my number line here is the 1 in my answer. So I always put that one in the middle. And really, when I get in a hurry, I don't even put other numbers on my number line for my answer and for graphing. But, you want to make sure that you get everything accurate. So on a number line, remember numbers to the right go up. So we're going to get bigger to the right, so 7, 8, and to the left they go down. So we'll go 5, 4. Okay, so here's a little portion of our infinite number line, not spaced out very well, but that's all right. So here, x, whatever x can be, we're going to represent with a shaded region. So I'm going to put that over here to the side. I'm going to say shaded region represents X. Okay, whatever shaded on our number line shows all the numbers that X could be to make this a true statement right here. Okay, so since we're talking about the 6 here, X is less than the number 6, I'm going to put a bubble, a circle on the number 6. So the shaded region represents anything X could be. Could X be equal to 6 in this case? No, it can't. It can be anything less than 6. So it could be 5.99999, something really close to 6, but it can't actually be 6. So I'm not going to shade in this bubble. I'm going to leave it open. But I am going to shade in all of the numbers on my number line that are less than 6, right? So I can either think about it. I know that 5 and 4 are less than 6, so I know I'm going to shade that direction. There's also a couple shortcuts you can use. On a number line that's infinite, you've got these 2 arrow ends. So one thing you can say is, all right, which arrow end matches my inequality symbol, right? This guy right here looks just like my inequality. This one does not. This is opposite my inequality symbol. This guy and this guy look the same. The other thing you can do is turn your inequality symbol into an arrow, right? And it's pointing in this direction, so I know I'm going to shade to the left. Uh-oh, I'm dropping things. So right directly on top of my number line, I'm going to shade everything to the left. So everything shaded, the part of the number line that's shaded represents all the numbers that X could be, right? It can be everything in between our integers and whole numbers, integers, whatever else. Everything on that number line. Okay, next important thing that I want to mention before I go on to the next type of inequality is that whenever you write your answer, you always have to write the variable first. So we're going to write that over here too. Variable, whatever it is, usually X or whatever letter you're using, always comes first. And what I mean by comes first is when we read an answer, an inequality from left to right, we have to start with the variable on the left. So we'll say on left. And I'll get down here, I'm almost done through my notes, but when I get to the bottom, I'll show you an example of when we don't have the variable on the left and we have to move it. Okay, so this is our less than sign. If I had X is greater than, let's say 4, using different numbers now. On my number line, I want to make sure I have a 4 there. That's my most important number since it's in my answer. And then you can add numbers going up to the right and numbers going down to the left. I'll add one number. Let's see, 5 this way, 3 going down to the left. Then I want to put my bubble over 4. Now, X cannot be equal to 4. It can be anything greater than 4, but it can't actually be 4. So I'm not going to shade this in. It is not part of my answer, my solution set. But I'm going to shade in everything that's greater than 4. X is greater than 4, so where are all of my numbers bigger than 4? This direction, right? And this side of my number line, this little arrow right here, matches my inequality symbol. They're both open the same direction. If I changed my inequality symbol to an arrow, it's, oh, I'm moving my paper, it's pointing to the right. So I know I'm going to shade all the numbers this direction. Every single number on my number line in the shaded region is a solution to this inequality. Okay, next two are X is less than or equal to, let's say, -1. So if I put a -1 in the middle, and I go up a couple and down a couple, 0, +1, -2, -3, I put my bubble. Now in this case, we have our inequality symbol with this, this line underneath it. This is X is less than or equal to -1. Since X could be equal to -1, -1 is in my solution set. So when there's a line under my symbol here, I'm always going to shade in my bubble. Now my number there is included in my answer choices, my solution set. So x is anything less than or equal to -1. All the numbers less than -1 go in this direction. And this arrow right here matches my inequality symbol. They're open the same way. Okay, and then lastly, I have x is greater than or equal to, let's say, 10. Okay, so if I put 10 in the middle and I have 11, 12, 9, 8, something like that, I would put my bubble over 10. Since I have this line underneath here, x is greater than 10 or x is equal to 10, I'm going to go ahead and shade 10 in. It could be my answer. Try and shade it in a lot. It's not perfect. Okay, and then shade in everything greater than 10. So greater than 10 is this direction. All right, so hopefully that simplified it a little bit for you. You can always go back and rewind that if you have to watch it over again. Okay, so no lines underneath the symbols, no filling in the bubbles. Lined under the symbols, shade in the bubbles. All right, so let's try a few kind of practice problems here. So we've got y is less than or equal to -3. So I'm going to put -3 right here in the middle of my number line. If you want to go up 1 and down 1, you can. -2 is up 1, -4 is down 1. I'm going to put my bubble here. Now, y is less than or equal to -3. It could be -3, so I shade this in. And then I'm going to shade in everything less than -3. Y is less than -3, so I shade everything less than -3. This arrow right here that I'm shading matches the direction of my inequality symbol, right? If I made this into an arrow, it's pointing to the left, so I know I have to shade to the left. Okay, B, this is the one I was talking about where x is not first here. X is supposed to be on the left and it's not. So we're going to rewrite it. We're going to flip these two sides. So I'm going to put x on the left and 5/2 on the right. Okay, since my inequality symbol is open towards the x, this is showing that out of these two numbers, x is bigger, right? The mouth is open towards the x. I want to keep it open towards the x. So since I flipped the sides, I have to flip my sign. I want the mouth open towards the x. So it's going to be in that direction. Okay, I don't want to change the value of anything. I just want to change the order that it's in. So I got to keep the mouth open. I call it a mouth. The inequality sign open to the same value. Okay, so now I can plot that on my number line. 5/2. And I put my bubble. And there is no line underneath here. 5/2, 5/2 cannot be a solution for my inequality. It cannot be x. So I don't shade it in. But I am going to shade in everything greater than 5/2. So I'm going to shade in everything this direction. X is any number greater than 5/2. So I'm going to shade all the numbers greater than 5/2. This arrow right here on my number line matches my inequality symbol, so I know that's the direction I shade. Okay, and then lastly, z is greater than 0. I'm going to plot 0 in the middle of my number line, put a bubble around it. There is no line under my inequality symbol, so that means z has to be bigger than 0. It cannot equal 0. So I'm not going to shade this in, but I am going to shade in all the numbers greater than 0. So this symbol, if I made it an arrow, it would point that direction. I know I'm shading this way. And this arrow end matches my inequality symbol. Okay, I hope that's making sense. A couple more examples here. I'm almost done. This video went a little longer than I intended. Okay, write and graph an inequality for the given scenarios. Identify a solution. Because of downtown Orlando's proximity to the Orlando Executive Airport, the heights of the buildings are under 450 feet. So if we wrote an inequality, the height of the building, they're less than 450 feet. Could they be 450? No, it says they're under 450. So the heights are less than 450 feet. So on my number line, I would try and put 450 in the middle. You can go up by 50s if you want. Doesn't really matter how much you go up. I'm gonna run out of space to write. and I'm going to put my little bubble here. Since there's no line, it can't be equal to 450. I'm not going to shade that in. 450 is not part of my solution set, but anything less than 450 is. So I'm going to shade in all these numbers less than 450. If you get confused about that, remember the little arrow trick shows you which way to shade. Okay, so if I wanted to pick an answer, would 350 be a solution? Is 350 under 450? Yep, sure is. What about 500? Is 500 over here under 450? No, it's not. That's why it's not shaded. None of these numbers would work, only these guys. Okay, next. For safety, all dogs at a dog park who weigh more than 50 pounds must play in area 2. So we'll say the dog that weighs more than 50 pounds, greater than 50. Does it say greater than or equal to 50? Nope, just more than 50. So dogs greater than 50 pounds have to play in a different area. So we're going to put 50. Here we can go up by 10s if we want, 60, 70, 80. Go down by 10s. Doesn't so much matter, just this middle number matters. So I put my bubble. There's no line underneath, so I can't shade in my bubble. Dogs can't be 50 pounds. It's only the dogs bigger than 50 pounds. They have to play in area 2. So all of the dogs in this weight range here. Right? So would a dog at 60 pounds have to play in area 2? Is 60 bigger than 50? Yes. Anything greater than 50. What about a 20-pound dog? Would they have to play in area 2? No, 20 is not part of my solution set. 20 is not greater than 50. So only anything above 50. All right. Next, write an inequality that represents the graph. So now we have the graph, we don't have the inequality. So here, I know the shaded region is x, or whatever variable you want to use. So I'm going to use x. And then I see that the number where my bubble is 4. I'm going to write a 4. Okay, I've shaded all the numbers smaller than 4, less than 4 in this direction of my arrow, right? So I know that my inequality symbol is going to look like this. My shaded part is anything smaller than 4, all these numbers. And since I have 4 itself shaded, that means it's included in my answers. So I'm going to put the line underneath here. Okay, let's try one more. All right, here I have a bubble over 2.5 and then everything shaded up above it. So I know x is my variable, 2.5 is the number in my solution. And I've shaded everything greater than that, right? Here's the side of the number line I've shaded. So I know it's going to look this way. And since I did not shade in the bubble, it's an open bubble, it means that x cannot be 2.5. It can be anything bigger than 2.5, but it can't actually equal 2.5. So I am not going to put the line underneath. So this is the inequality represented by this graph. All right, if you have any questions, my students, let me know, and good luck.